Hi folks, and welcome to Higher Tables and Graphs on Spreadsheets. I'm going to be using Google Sheets for this tutorial because it's available to everybody, and in my experience it has everything you could need, really all the way up to advanced higher. There are a couple of weaknesses in it compared to Excel, which is obviously a far larger program, but I'm going to show you workarounds for those that are really pretty easy to apply. So we're going to use our data from our frequency versus volume in a bottle, volume of water in a bottle experiment. So I'm just going to start popping in the top of my data table here in milliliters, and we very quickly get to our first issue, which is putting in special characters like plus or minus. Now I've got a pretty easy workaround for this. If you just open up a Google Doc, and you just insert a special character into your Google Doc. Now the Google Docs insert special characters is really lovely to use because they have the draw function and it will recognise things really easily. I've slowed myself down here the speed of what I'm doing so that I can speak over it a little bit easier. So that's why my mouse sometimes seems like it's hovering over things for a while. But you just draw the kind of thing you want, it'll recognise it, gives you some options. You just go highlight it, Control C for copy, head back over to your data table, and Control V, paste it into your cell. And carry on as normal. And that is the fix for putting special characters into Google Sheets. It's really not a problem at all. I just usually have just a random doc open next to my Google Sheet if I need any special character anytime. The only thing it won't allow you to do is copy and paste superscript or subscript numbers over, but don't worry, I've got a fix for that, which I'll show you at the end. So here I'm just double clicking on the edge of the cell to make the whole column the right width for that title, which is a nice little shortcut. So you just pop your mouse over the edge of the cell and it'll show you a little double-ended arrow. And if you double click on that double-ended arrow, it will put the cell to the right width for whatever you've typed into it. So I'm going to pop in my frequency as well. Make a little mistake here. And my measuring certainty was 0.01 Hertz. So everything that you would put into your manual table, you pop into your digital table. And again, I'm just going to go up there, double-ended arrow, double click, and it'll make it the right width. So now we need to start putting in space for our repeats. So just go to one row below. So 5 repeats across, and the mean. And our delta R, our random uncertainty. So again, delta is a special character. So I go down here, draw something that looks something like a delta. That's the wrong symbol. So if you hover over the symbols, it will tell you its official name. So there we go, there's the delta. Highlight it, copy, and paste it into your cell. So it's probably going slow enough here because I'm putting myself on half speed. You could be going along with me and just pause if I'm getting ahead of you. So if you want to be making your table alongside this tutorial, you don't have to necessarily watch through the whole tutorial and then do it. There's a lot of information here, and it's a pretty dry thing to watch without doing anything. So I'd really suggest, if you have access to a computer separately, that you have a go at this tutorial. I will say that the iPad is a really tough place to use spreadsheets. It's pretty clunky. So you really want to try and get onto a laptop or a PC or a larger computer if you can, with a mouse mat and a keyboard. So I'm just popping my border on here, which is not something I would do in a manual graph, but I think it's worth it for a digital graph, because of course you can change the size of it at any time. So I'm just highlighting here. I had 6 sets of data down, so that is 6 lines for my data underneath my repeats there. And now I'm just going to pop on one of my separation lines. So one of the annoying things is this frequency title is of course all the way over the left, but accounts for all of these boxes. There's an easy way to take care of that. If you just highlight all the boxes to the right of it and use this merge cells button just there. And then if I ask it to sit in the middle of its assigned cell, it'll go there right there in the middle. Okay, so that merge cell button is a really good one. So now I'm just going to start popping my borders onto these titles. I'm going to make them sit in the middle, those numbers and letters sit in the middle as well, because it just looks nicer. And I'm going to bold my overall titles. And these are all just like nice formatting options. At the end of making this table, you can literally just copy and paste it into any other experiment. So you only really have to go through this formatting one time really, and just go and grab it for any other experiment. And that is one of the useful things about doing it on Google Sheets, guys. It'll always be available to you no matter where you are, what device you're on. You could always just go and copy one of these table templates. So I click this button, but then I remember that I do not like to have masses of lines separating things unnecessarily. So I'm going to put an overall border, and I'm just going to put a separation between my mean and my repeats, and my mean and the random uncertainty. Again, making sure that those separation lines between your mean and random uncertainty do not go up into your overall title. If you separate your means and random uncertainties from those units, you will lose your unit mark. I'm just going over to the volume now, just to make this look a bit nicer. I can merge these vertical cells so that they become all one, and then just to the right of the alignment is vertical align, and I can make them sit in the middle of that big cell, and that just looks nicer, okay, because the volume doesn't have as many things going on as the repeated frequency. Do my little box around that, and then I have my finished table. And there you have a table for all of higher that should pretty much do you for every single experiment. And what I'm going to do now is just quickly show you, of course, that you can just highlight the whole table, copy and paste it, delete the titles, and you've got a blank table template ready for any experiment. It may be that you want to do some calculations in your experiment, maybe a square of something, or a sine or a cos or a 1 over, and those would be columns that would be put on the end of this template. So this template would stay as it is, and then any manipulation of data goes at the end of the template, so it would be added columns. And they would have separate units, because if, for example, if I did f squared, then that would be a Hertz squared unit. So we're going to populate this table now and have a look at the real power of doing tables on spreadsheets. There is a very good reason why you should go through this and learn how to do a table on a spreadsheet. So this is my data from the frequency and volume experiment. I'm not going to make you put in every single one of your data values unless you really want to. I'll just get you to do a couple of lines so you can practice using the formulas that I'm about to use, as I struggle to work out how to get back to my previous sheet. There we go. So I'll just paste these in. Remember, my screen is still working at half speed, so sometimes it looks like I'm going pretty slowly. For some reason, when you paste stuff in, it gets rid of your previous formatting, but you can pop those lines back in later. So here's one of the first things. So I'm going to be putting in my volumes here, 100, 200. And if you're doing a sequence, you just highlight the first couple of bits of the sequence, 100 and 200. The spreadsheet will recognise that. You pop your mouse over that little blue square in the bottom right hand corner and drag that blue square down, and it will repeat that sequence for you as long as you want. Now here obviously it wouldn't have taken me long to type in those numbers, but for much larger sequences it's really, really useful, and we're going to see it in a far more powerful way in just a second. So let's do our means. So we're going to ask the spreadsheet to do a calculation for us now. So we click into our cell, and to tell the spreadsheet you want it to actually do the calculation, you need to press equals. So then you just start typing what you want it to do. So the word average. So I just start typing average. and it starts predicting what you would like, and you just click on the thing you want, which is average. So you click there. You then highlight the list of values you want it to average, so your 5 repeats all on the same row. You then close the bracket from your keyboard and press enter. Now, as you can see here, it's given me an average to too many sig figs, but we'll deal with that in a minute. I'm going to hover my mouse over that blue square, click and drag down. And now it has repeated that process correctly for every other row in my table. Now, you've got to agree, that's helpful. Now, we just said it was too many sig figs, so I'm going to go and use this please decrease my decimal places button, which is nice, lovely up there. And now it's all correctly rounded off. You don't have to worry about rounding incorrectly. That's a really powerful tool of digital tables. So here we go with random uncertainty. I cannot take credit for this method. One of my pupils messaged me with it. So we're going to say equals and open a bracket and then just start typing the word max. And the first option that comes up is to highlight a selection of things where you would like the spreadsheet to find its maximum value in that set. Close that little bracket, minus, and then say min. And again, select the first value, the first option, and go and highlight exactly the same set of numbers you would like the spreadsheet to find the minimum in. Close the bracket. Close the brackets around that whole set and then say divided by 5. Press enter. And now you can click on it, click the little blue square and drag down, and it will apply that calculation to all of your other sets. And as you can see, I'm already set to a single sig fig here. That's quite unusual that the spreadsheet would automatically do that. It's because it's not the first time I've done this process in these cells. So if you're not, make sure you reduce your number of significant figures down to 1 using the decrease your decimal places button just at the top left there. I've also copied some weird formatting quirk as I've pulled down, so I'm just clearing my borders and putting a large one around the outside. Like I said, guys, I did not come up with this method myself. As simple as it seems now, I cannot believe I haven't come up with it in the years that I've been doing this. So thank you very much to the people who messaged me with it just a few days ago. Now here we get into that problem again where my random uncertainty is to 1 decimal place and my means are to a single decimal place. But now that we're on the digital table, I can fix that straight away without having to rub out or anything. So I just go and highlight my mean column, go up to that reduce decimal places button and bring them down. Perfect. And we are ready to make our graph. So a lot of people find graphs quite intimidating at the best of times, and I know making them on spreadsheets feels like a lot, but I'm going to show you a method that will work every single time and really should become very quick. Now, the first big thing that you can do to make making your graph simple is only highlight the y-axis values. So I'm going to highlight just our mean frequencies and then insert the graph. And what this avoids is the common issue of the graph putting 2 sets of data on 2 separate lines on your graph. So now what we do is we obviously need to add in our x-axis values, and you can see here that my Sheets has just given me a scatter graph because it's learned that's always what I want, but yours will often give you a bar graph first. So just go down to chart type and always select scatter graph. That's always what you want. We now need to add in our x-axis, which is our volume values. So you click x-axis and then the little square grid symbol on the right, and that allows you to go and highlight those values. You've got to click that little grid symbol to highlight the values, otherwise you have to type in the cell codes. Say OK, and there goes our x-axis. Okay, so that's now a graph where you absolutely know the y is on the values you want for the y-axis are up the side, the values you want for your x-axis are along the bottom. So we're now just going to go through a series of things that you should always check to make sure that your graph is of higher quality. Now, when you do your assignment in Higher, you most likely will not do a digital graph. You are going to do a manual graph in your assignment. However, at any time after hire, if you're in any job or course, including advanced higher physics, where you're doing a graph, you will not be doing a manual graph. Okay, people do not do manual graphs nowadays. We do digital graphs. And so these are very important skills. The first thing you're going to do is go down to gridlines, which is the bottom option in the customized menu, and set all of your major and minor grid lines to 10 for the horizontal axis and for the vertical axis. And now you can see it looks a lot more like graph paper. The next thing I'm going to do is I'm going to make sure that both of my axes start at 0 by going into my vertical axis and horizontal axis and setting my minimum value. Now that was already the case here, but it's often not. Next, we're going to go up to chart and axes titles and pop our labels onto our X and Y axes. So these are something that's quite often forgotten in digital graphs, but just as essential. So it's really easy here. You just do horizontal axis title and just type it in. It will often automatically give you a chart title, overall title. Those really aren't necessary in physics, so I usually just delete it. Next folks, a major issue here now is because we've made our major and minor grid lines so small that our actual point is larger than a box, and that will lose masses of marks. So we need to change our points into X's, and then we make them smaller. I find 3 is quite a nice size, still large enough to see. And so you see we've got nice dainty little X marks that show you exactly where your point is. And we're going to add in a trend line. So that's in the series section here, just a little bit lower down. Just click trend line. It'll always go for a linear one first. Now, annoyingly, I've chosen an experiment that does not have a linear relationship. I've really not got much idea what the relationship is here at all. Pretty much all the experiments you do will be about a linear relationship, so you don't have to worry too much about this. But you can just try kind of trial and error for the shape. If it's not linear, that seems to work relatively well. Polynomial, I can probably maybe change the power of it and get it even closer. Is it an expo? No, it's not. So like I say, folks, this is something you usually would not have to worry about majorly, although now and again you will do a 1 over graph or an x squared graph, and you'll get a curve, and then you'll do some further processing. You'll either square your x-axis, or you'll do 1 over x squared. You've got one of those in higher as well, and see that it becomes a straight line. So you don't get a straight line graph every single time, but most of the time you still are getting straight line graphs in higher. There we go, that fits pretty neatly. So I've just popped it back to a linear line for a second to show you the next thing that you might want to do. So once you've got trend line, if you scroll just a little bit further down, under label you can say use equation. Now I agree this is a slightly odd place to bury seeing the equation option, but it's in label. You have to click trend line, and then it's in label use equation. So I'm putting it back to a polynomial now because obviously that's the one that fits. And especially for your linear line graphs, you would never really be expect to access an equation like this one, but for the linear line, your y equals mx plus c equation is fantastic, because then of course you can immediately see the size of your gradient. And that's usually the thing you want from your linear graph. So the one thing we haven't looked at in this example is putting a label such as T squared into a cell of your spreadsheet. In Google Sheets, that is pretty tough because it does not have a superscript or subscript option for the cells like Excel does. Now I've gotten this neat little workaround for that. Some lovely person on the internet has put together this copy and pastable cell that they have worked very, very hard to put superscript and subscript numbers into. There are a number of ways you can do it using things like char codes, but it's just more than you need to get into. This is brilliant. You can just paste this little cell into your spreadsheet. You then just replace the X with whatever it is you want the label to be. Could even be one of your special characters. You delete all the superscript and subscript numbers that you don't want, and there you go, we have a T squared label. I can then take the bold off it, I can make it any size I want, I can drag it around my cell, and that is a perfectly good label. I can copy it and paste it into another cell, and it's totally stable. The only thing this doesn't allow you to do is have subscript letters, which can be a little bit frustrating. So you can't have like a F for final or an I for initial or things like that. But that's more of an issue in an advanced hire. And to be honest, markers are very aware that it's difficult to get superscript and subscript in a lot of spreadsheet programs. So they're not going to be taking marks off for that. So I'll attach this spreadsheet of superscript and subscript templates in the description of this video, and you can literally just open it up and just copy it. You just click on any of the cells. I've only put loads of cells here just in case as people open it they delete one by accident. There's just loads of cells. You just Control C and then Control V into your own spreadsheet. I would even recommend having a spreadsheet like mine specifically dedicated to having a bunch of these cells to copy and paste, and then it'll always be available to you. Well, that's it, folks. Time to go and try making your own graph of your frequency and volume data, and I'll see you in the next video for our Measuring G experiment.